Today we're going to be expanding on what we know about the laws of exponents and looking at negative exponents. First, we're going to look at what negative exponents are and how we get them. So first, let's have a look at this question over here. 3 to the power of 4 divided by 3 to the power of 9. We're going to look at two different ways of working out what this is, or of simplifying this. Okay, so if I take 3 to the power of 4 divided by 3 to the power of 9, and I simplify it using cancellation. So I write it as a fraction. So this is the same as 3 to the power of 4 over 3 to the power of 9, which I can then write like this. 3 times 3 times 3 times 3 over 3 times 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 3. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9 3's at the bottom and 4 at the top. So 3 to the power of 4 divided by 3 to the power of 9 means 4 3's multiplied together at the top divided by 9 3's multiplied together at the bottom of the fraction, and we're dividing them. Okay, now when we are simplifying this, what we're actually going to be doing is cancelling out the common factors. We're saying 3 goes in there once, 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 3 goes in there once. And then I can't cancel anything else out because there's nothing else at the top that I can cancel out with the 3's on the bottom. So what I'm left with over here is 1 times 1 times 1 times 1, which is 1, over, at the bottom, 1 times 1 times 1 times 1, which is 1, times 3 times 3 times 3 times 3 times 3. So there are 5 3's. So that's 3 to the power of 5. So if I simplify it by writing it as 3's multiplied together over 3's multiplied together, and I cancel out my common factors, I end up with 1 over 3 to the power of 5. So that's one way of simplifying that expression, 3 to the power of 4 divided by 3 to the power of 9. But now let's have a look at another way of simplifying it by using what we know about the laws of exponents. Now the laws of exponents say that when we are dividing things that have the same base, powers with the same base, we subtract their exponents. So based on the laws of exponents, I should be able to say that 3 to the power of 4 divided by 3 to the power of 9 is the same as 3 to the power of 4 minus 9. Okay, now what do we get when we subtract 9 from 4? We get negative 5. So that is the same as 3 to the power of negative 5. Now these were both the same question, and this is what I ended up with by doing it in these two different ways. 1 over 3 to the power of 5 and 3 to the power of negative 5. What that means is that these are the same as each other. So now I can say, therefore, 1 over 3 to the power of 5 is the same as 3 to the power of negative 5. So if I've got a negative exponent, what it actually means is that it is in the wrong place in a fraction. If I want this exponent to be positive, I need, at the moment, you can't see it, but this is over 1. Okay, remember, if something doesn't have a denominator, it means that it is over 1. So it's a numerator at the moment. If it has got a negative exponent, it means that I can make that exponent positive by moving it to the other part of the fraction. If it's at the top of the fraction, I move it down to the bottom of the fraction, and then the exponent will become positive. So I can write it with a positive exponent by writing it like this at the bottom. I can also do the same thing the other way around. If I've got a negative exponent and it's at the bottom of the fraction, I can move it up to the top of the fraction and the exponent will become positive. Okay, so let's have a look at our rule over here. So the rule for negative exponents is that when a power has a negative exponent, we can make that exponent positive by moving the power up or down. So if it's in the numerator, we move it to the denominator, and vice versa. If it's in the denominator, we move it to the numerator. And when we move it, that negative exponent is going to become positive. We make the exponent positive. Now, it's much easier to work with positive exponents than to work with negative exponents. So it's always a good idea when we start a question, if you are given a question that contains negative exponents, change them to positive as soon as you can. Now, you can't necessarily do it straight away. Sometimes you have to do other things first before you can change it, but change it to a positive exponent by moving it up or down as soon as you can. Also, when you finish your question, you need to try and make sure that you leave your solution with positive exponents. Okay, so basically, if you've got a to the power of negative n, so if you've got a base with a negative exponent, then remember that is the same as having a to the power of negative m over 1. If you can't see the denominator, it means that it is over 1, so it is in the numerator. Okay, so you need to imagine that it is over 1. If I want to make that exponent positive, then I need to move this to the denominator. If it's in the numerator, I move it to the denominator, and when I do that, the exponent is going to become positive. It changes from negative to positive, so it changes sign. So that means that a to the power of negative m is equal to 1 over a to the power of m. Okay, now we can do the same thing if the a to the power of negative m is in the denominator. If it's in the denominator, then we're going to move it up to the numerator. And when we move it up, the exponent is going to become positive, and that is the same as a to the power of m. Okay, so 1 over a to the power of negative m is the same as a to the power of m. Okay, right, so now let's have a look at our first example for today. In this example, we've got 3 to the power of negative 6 in our numerator, and then in the denominator of our fraction, we've got 2 to the power of 10 times 5 to the power of negative 4. And we need to simplify this. Now, in this particular example, we're not going to be able to do any simplification in terms of cancelling things out or anything like that, but we're going to change things and make sure that they have positive exponents. Remember I said we always need to try and make sure that we leave our solution with positive exponents. Okay, so let's have a look at how we do this question. Okay, so here I've got my question. We've got 3 to the power of negative 6 over 2 to the power of 10 times 5 to the power of negative 4. So in this question, all we're doing is practicing moving things so that they have positive exponents. So we said in order to change something to have a positive exponent, we need to move it up or down. If it's at the top of the fraction, we move it down to the bottom. If it's at the bottom of the fraction, we move it up to the top. And when we move it, the exponent is going to change sign. So over here, I want to move the 3 to the power of negative 6 because it has the negative exponent, and I want to move the 5 to the power of negative 4 because it also has a negative exponent. I'm not going to move the 2 to the power of 10 because its exponent is already positive. Okay, so let's have a look at the top over here. There isn't anything that doesn't have a negative exponent. Everything here has a negative exponent, so I'm going to be moving everything that's in the top. Now, if I wasn't going to move anything to the top, I would then have to write a 1 in place of anything that I'm moving out of its way. But because I am going to be moving the 5 to the power of negative 4 up to the top, I don't need to write that 1. I can just write what this is going to change to. So when I move the 5 to the power of negative 4 to the top, it becomes 5 to the power of positive 4. And then over here at the bottom, I already have my 2 to the power of 10, which isn't moving because it already has a positive exponent. And the 3 to the power of negative 6 is going to move down to the bottom. It becomes times 3 to the power of positive 6. So when we move things, if there's more than one factor or power in our fraction like this, then when we move things, we need to make sure that we have multiplication in between them if there are other things that we're moving, where we're moving it to. Okay, so like over here, when I moved the 3 to the power of negative 6 to the bottom, there was already something else there, so I had to say 2 to the power of 10 times 3 to the power of 6. Okay. And that is like that. Okay, so that's what you should get for that question. So I'm going to give you a few that you're going to do for yourself, practicing just moving things so that you can get used to applying this law. Okay, so let's go and have a look at the first one you're going to do. Here you've got 2 to the power of negative 3, and you need to write this with a positive exponent. Okay, so I'm going to give you 30 seconds for this question. Okay, so let's go through that and see what you should have got. So first of all, what you had to remember with this one over here is that even though you can't see it, 2 to the power of negative 3 is if we were to write it as a fraction, it is over 1. So it has a denominator of 1, and it is currently in the numerator. So if we want to write this as with a positive exponent, we need to move it to the denominator. And because I'm moving it to the denominator and there is nothing else left there still, and I'm not moving anything else up, what I'm left with at the top is going to be 1. So it's going to be 1 over, and then when I move this to the bottom, the base stays the same, but the exponent is going to change sign from negative to positive. Like that. So you should have got 1 over 2 to the power of 3, which you can then simplify to 1 over 8. Okay, so that's what you should get for that question. Right, now let's go and have a look at the next one. Here you've got 1 over 3 to the power of negative 2. Okay, so I'm going to give you 30 seconds for this one as well. Okay, so let's go through that one quickly. So in this one, our negative exponent is in the denominator, okay? Or our power with the negative exponent is in the denominator. So I'm going to be moving it up to the numerator. Now, if I write this as 3 to the power of positive 2 in my numerator, it is over 1. When I move the 3 to the power of negative 2 up, there's nothing else left behind here, so it's over 1. But now I don't have to write that 1 because there's nothing else there. And when you've got a denominator that's 1, you don't need to write the denominator. So we can just write it as 3 to the power of 2. And then that is equal to 9 if I write that in standard form. Now remember, you need to make sure that you change things to standard form when you are able to, when it's reasonable to do that. So 3 to the power of 2, you should know that that is equal to 9. Just like in the previous one, we had 2 to the power of negative 3. You should know that that's equal to 8. So then you're expected to change it. If it was 3 to the power of 20, then you wouldn't change it. You would just leave it. Okay. Right. Let's go on to question C. Here you've got 7 to the power of negative 4 times 3 to the power of 8 times 5 to the power of negative 7 all over 2 to the power of negative 6. Okay, so I'm going to give you 1 minute for this one. Okay, so let's go through that one and see what you should have got. So over here, I have got my 7 to the power of negative 4 times 3 to the power of 8 times 5 to the power of negative 7 in my numerator. The only one over here that doesn't have a negative exponent is the 3 to the power of 8, so it is not going to move. The other two have negative exponents. They are going to move. In my denominator, I only have one power and it has a negative exponent, so it is also going to move. So I'm going to start off in my numerator by seeing what is not moving. The 3 to the power of 8 is not moving, so I need to write that one down. It's staying where it is. Then I have in the denominator the 2 to the power of negative 6, which needs to move up to the top. So that's going to come up here and become 2 to the power of 6. Okay, then that is over because these are moving, so they're not going to be there anymore. In my denominator, I have nothing that's staying behind, so it would have been 1, except that these are now moving to the bottom, so it's not 1, so I have to write my denominator. So the 7 to the power of negative 4 is going to move to the bottom and become 7 to the power of 4 times 5 to the power of negative 7 becomes 5 to the power of 7 at the bottom of the fraction. And now this is not reasonable for you to have to change because these are all going to be big numbers to work with. So we don't expect you to change one like that. So you can leave it like that. Right, so that's question C. And then question D. we've got in brackets 2 over 3 to the power of negative 1. Okay, so I need to give you 30 seconds for this one. Okay, so let's go through that one quickly. So over here, my base of my power is 2/3. Now there are two ways of doing this. What you can do is you can use the law that we have for when you are raising a product to a power, where we take this fraction and we use the numerator and the denominator as separate factors, and we raise each of them to the power. So what this would be then is 2 to the power of negative 1 over 3 to the power of negative 1, and then we would take those negative exponents and we would apply them and change them to positive, and that would make this become 3 over 2. But there is a quicker way of doing this. So over here I've got 2 over 3 to the power of negative 1. The other way of doing it is to take the whole base, which is the fraction, and say when I change this exponent to positive, then anything that's in the denominator is going to move up, and anything that's in the numerator is going to move down, and we invert the fraction. So it's become 3 over 2, and now this is to the power of 1, because now it's changed from negative 1 to positive 1, but when you've got something to the power of 1, you don't have to write that power of 1. So this I don't need to write, it's just 3 over 2. If it was squared, then it would still be squared. Or so if it was to the power of negative 2, then it would still be squared. But because it's to the power of 1, I don't need to write that. So 2 over 3 to the power of negative 1 is the same as 3 over 2. So when you've got a negative exponent for a whole fraction, then that whole fraction is going to invert. It's going to flip over. Okay, right. Now let's have a look at some examples where we're going to actually be using this to help us to simplify more complicated expressions that involve other laws of exponents as well. So in this question, we've got in brackets 10 to the power of negative 1 times 4 cubed over 2 to the power of negative 3 times 5 to the power of 4, and all of that is squared. Then we're dividing that by 5 squared to the power of negative 2 times 20 cubed, all in brackets. Okay, so now let's have a look at how we do this question. Okay, so here I've got my question. Now there is a lot that is going on in this question. There's a lot that we're going to have to do. Okay, but the very first thing I'm going to do is I'm going to look in this fraction over here and see, because I've got negative exponents, I'm going to move the things that I can move now. Okay, so I'm going to start with this fraction, and I'm going to move the 10 to the power of negative 1 and the 2 to the power of negative 3 up and down. So I'm going to be left at the top with 4 to the power of 3, which isn't moving, times, and then the 2 to the power of negative 3 is moving up to join it and becomes 2 to the power of 3. And that is over. At the bottom, I've got 5 to the power of 4 that was already there, times, and then the 10 to the power of negative 1 is moving down and becomes 10 to the power of 1. But now I don't need to write that 1 because 10 to the power of 1 is the same as 10. Okay, and that is still all being squared, and it is still divided by, over here, this whole thing is together. Okay, so I'm dividing by all of it. That's why it's in these brackets over here. Okay, so now this over here, it doesn't look like a fraction at the moment, but it can all be written over 1. So I've got over here 5 squared to the power of negative 2. Now because the negative 2 is outside the brackets, I can change that to positive by moving the whole 5 squared, which is the base of that power, down to the bottom of this fraction. Okay, so that gives me 20 cubed over 5 squared to the power of positive 2. So I took the 5 squared to the power of negative 2 and I moved it to the bottom of the fraction. Even though it didn't look like a fraction, it is over 1. Okay, so I moved it to the bottom and it became 20 cubed over 5 squared in brackets to the power of 2. Okay, so that's what I end up with. Now, because I now have it written as a fraction, I don't need to still write those square brackets, because the brackets were helping me to know that I'm dividing by all of it, and I'm not just dividing by that and then timesing by the 20 to the power of 3. But because it's now been written as a fraction, I don't need to have those brackets there anymore, because the fraction is holding it together in the same way the brackets would. Okay, so now let's go on to the next steps. Now we've moved our negative exponents, got rid of them, now everything is positive. Okay, now let's go and have a look at what next we need to do. So in this over here, I have got a base of 4, I've got a base of 2, I've got a base of 5, and I've got a base of 10. So as it stands over here at the moment, I can't use any of my laws of exponents that I have to simplify what's in this fraction over here. I have to change bases so that I have the same kinds of bases. I've got over here a 2 and a 5. Those are prime numbers. The 4 and the 10 are not prime numbers, but they can be written in terms of 2s and 5s. 4 is the same as 2 squared. So this is 2 squared cubed. Remember, when we change a base, we put it in brackets if it has got an exponent. So the 4 is the same as 2 squared in brackets, and it is being cubed. Times 2 cubed, and then that goes over. In my denominator, I've got 5, which is staying as it is, times, and then the 10 is the same as 2 times 5. Now the 10 doesn't have an exponent. I mean, it does, it's 1, but I don't have to worry about that because the exponent of 1 doesn't actually do anything. So because it doesn't have a visible exponent, I don't actually have to write this in brackets. I did there because the 4 had an exponent that I was still going to have to deal with in the next step. So over here, I'm just going to write 2 times 5. You can put it in brackets if you want to, but it's not necessary. Okay, so now I've changed all of those so that they have got bases that I'll be able to work with to be able to simplify this further. And that is all still being squared, divided by, over here I'm going to do the same thing. The 20 is also not a number that I'm going to be able to work with all of the other stuff that I've got here. So the 20 is the same as 4 times 5, but 4 is also not going to work for us because we don't have any 4s here anymore. So I'm going to change the 4 to 2 squared. So 20 is 2 squared times 5. Now, if you were to do the ladder method to be able to write 20 as a power of its, or as a product of its prime factors, you would end up with 2 squared times 5. So 20 is the same as 2 squared times 5. And all of that, the whole of the 20, is being cubed. Okay, so that is over what I've got at the bottom here, 5 squared squared. Okay, now I could have simplified that now already, but I'm just going to do all of my raising powers to powers in the next step. Okay, so now I've reached the point where I have got all the same kind of bases that I'm going to be working with. Now I'm going to go and get rid of all of these brackets that I have where I've got powers inside powers. I'm not going to be able to get rid of these ones yet. Okay, that I'm only going to be able to get rid of a little bit later, but let's go and sort out the stuff inside here, getting rid of those brackets and these brackets and those brackets over here as well. Okay, so I'm starting off with this one over here, 2 squared to the power of 3. Remember, when we are raising a power to a power, we keep the base the same, so it's still going to be 2, and then the 2 and 3 are multiplied together, giving me to the power of 6. Times, this is 2 cubed, and that is over 5 to the power of 4, times 2 times 5. Okay, that is all still squared. I'm not doing anything with that square yet. Divided by, over here, I'm going to be raising each of these to the power of 3. So 2 squared to the power of 3 is 2 to the power of 2 times 3 is 6, times 5 to the power of 3 is 5 cubed over there. That goes over. And at the bottom, I also have to raise 5 squared to the power of 2. That gives me 5 to the power of 2 times 2, which is 4. Okay, so now I've got rid of all of the inside brackets. Now what I'm going to do is I'm going to simplify these fractions so that I have less to write. And then I'm also, after that, going to get rid of these brackets over here. Okay, so over here, I'm going to simplify this fraction by cancelling out anything that I can. So over at the top, I've got 2 to the power of 6 times 2 to the power of 3, and at the bottom I've got 2. So I can cancel out this 2, which is to the power of 1. You can't see it, but it's got a power of 1. With, it doesn't matter, either one of these. Okay, so that's going to be 2 to the power of 6 minus 1 is 5. And that leaves me at the top with 2 to the power of 5 times 2 to the power of 3, which if I multiply powers with the same base, the base stays the same and I add the exponents. So it's going to be 5 plus 3, which gives me 2 to the power of 8 at the top. And that's all I'm going to be doing with my 2's. Now I'm going to go and do my 5's. There were no 5's in the top. In the bottom, I've got 5 to the power of 4, and I've got times 5. That gives me 5 to the power of 5. So at the bottom of my fraction here, I've got 5 to the power of 5. Okay, and that is still squared. I still haven't done anything with that square yet. And it is divided by, over here, I can simplify the 5 cubed and the 5 to the power of 4. 5 cubed goes in there once. 5 cubed goes in here. If I divide it, I get 5 to the power of 4 minus 3, which is 1. So I don't need to write that one, it's just 5. So 2 to the power of 6 over 5. Okay, the next thing I'm going to do is I'm going to go and get rid of these brackets now over here. So when I get rid of these brackets, I'm going to be squaring the top and the bottom of my fraction, raising each of them to the power of 2. So I've got 2 to the power of 8 squared, the base stays the same, and I multiply the exponents. So 8 times 2 is 16. So that's 2 to the power of 16 over 5 to the power of 5 squared. The base stays the same, so still 5, and then I multiply the 5 by 2, and that gives me 10. So it's 5 to the power of 10. So I've got 2 to the power of 16 over 5 to the power of 10. And then I'm going to be dividing by this fraction over here. Now, we know when we are dividing common fractions, we need to tip and times. So I'm going to do that now, so I'll be ready to do my cancelling and my timesing in the next step. So I'm going to tip and times now, and that gives me times 5 over 2 to the power of 6. And now I'm going to go and simplify by cancelling things at the top with things at the bottom that I can. So over here, I've got 2 to the power of 16. I can't cancel that with this, but I can cancel over here. I've got 2 to the power of 16 and 2 to the power of 6. They've got the same base, which means I can divide them. So if I divide, remember, I'm going to end up with my result is going to be where the higher exponent is. So 2 to the power of 16 minus 6 is 10. That's going to become 2 to the power of 10. And over here, this cancels out completely. Then the 5's, the same thing happens, except that my higher exponent for the 5's is in the denominator. So I'm going to have 5 to the power of 10 minus the one that you can't see, which gives me 5 to the power of 9. Okay, so this cancels completely, giving me 1 over there. So I end up for this question with 2 to the power of 10 over 5 to the power of 9. And now, when you get to that point, 2 to the power of 10 and 5 to the power of 9 are both very big numbers that we don't expect you to know. So it's not reasonable to expect you to have to then go and simplify it or to write it in standard form. So you can leave it like that. Okay, so now I'm going to give you one that you're going to try for yourself. In this question, you've got 6 to the power of negative 2 times 4 squared, and that is all over 3 to the power of negative 1. Okay, so I'm going to give you 1 minute for this question. Okay, so let's go through that question and see what you should have got. So we start with our question over here. The very first thing we're going to do is we're going to move things that have negative exponents and make them positive. So the 4 squared is going to stay where it is because it has a positive exponent already, but the 6 to the power of negative 2 and the 3 to the power of negative 1 both need to move. So the 4 squared is staying at the top, times the 3 to the power of negative 1 is going to come up and join it, and it changes to 3 to the power of 1, which is just 3. Then at the bottom of my fraction, I'm now going to have 6 to the power of negative 2 going down and becoming 6 to the power of positive 2. Okay, now you can't just stop there, but none of these have got the same base, which means that at this point, as it stands right now, I can't simplify anything further. So I need to change the bases to make them the same, or so that they have the same numbers in them, so that I will be able to go and simplify further. So the next step is to change things to have prime numbers. The 3 over here is going to be the same as over here. I can change the 6 to 2 times 3, but then I also need to have 2 with this 4 over here. So the 4 is the same as 2 squared, and that the 4 was already being squared, so I still have a square outside over there, times the 3 is staying as it is, over the 6 is the same as 2 times 3. It has to go in brackets because 2 times 3, it has to go in brackets because it has got an exponent outside. Okay, so now let's go and get rid of those brackets that we just put in when we were changing our bases. So the 2 squared to the power of 2 is going to become 2 to the power of 2 times 2, which is 4, times the 3, which is already there, which isn't changing. And the bottom, I'm going to have 2 to the power of 2 times 3 to the power of 2. Okay, now we can go and simplify. So the 2 to the power of 4 over 2 squared, I can simplify that by saying the higher exponent is at the top. So I'm going to have 2 to the power of 4 minus 2, which is 2 at the top, and this is going to cancel out completely. Then the 3 and the 3 squared, the higher exponent is at the bottom, so this is going to cancel out completely, and this is going to be 3 to the power of 2 minus the 1 that you couldn't see. So 2 minus 1 is 1, so it's going to be 3 to the power of 1, or just 3. So I'm going to end up with 2 squared over 3. Okay, so now we look at both of those numbers and we see, is it reasonable for us to change that? Now, in this case, it is reasonable because 2 squared you should know is 4, and 3 is already a normal number. It's already in standard form. So you should have ended up with 4 over 3 for this question. Okay, let's go and have a look at the next one. In question B, we've got 10 to the power of negative 2 times 2 cubed, and that is all over 5 to the power of negative 1 times 4 to the power of negative 2. So I'm going to give you 2 minutes for this question. Okay, so let's go through that question and see what you should have got. So first of all, just like in the previous one, I'm going to move anything that has a negative exponent so that they all become positive. Okay, so over here, I've got 10 to the power of negative 2 that has to move. The 2 cubed is going to stay where it is, and both of these are going to have to move. So at the top of my fraction, the 2 cubed is still going to be there, and it's joined by 5 to the power of negative 1, which moves up, becoming 5 to the power of positive 1, which is just 5, times the 4 to the power of negative 2 is also going to move up and join it, becoming 4 to the power of positive 2. And that is all over. There's nothing that's staying behind, so it would have been 1, except that the 10 to the power of negative 2 has to move down and becomes 10 to the power of positive 2. Okay, I'm now going to go and continue with this using my other laws of exponents and cancelling things out where I can. So first, before I can do that, I have to make sure that I've got bases that I can work with. So the 2 and the 5 are already prime numbers. The 4 I can change to 2 squared. So that's going to be 2 cubed times 5 times the 4 becomes 2 squared, and that is still being squared, over, in my denominator I've got 10 squared, which is 2 times 5. That has to be in brackets, and that is being squared. Okay, so now I'm going to go and get rid of those brackets that I've put in there when I change the bases. So that becomes 2 cubed times 5 times 2 squared to the power of 2 is 2 to the power of 2 times 2, which is 4, over. In the denominator, I have 2 squared times 5 squared. Okay, so now we can go and cancel out the things that have the same bases, or we can simplify the powers of the same bases. So I've got 2 cubed and 2 to the power of 5 at the, or 2 to the power of 4 at the top, and the bottom I've got 2 squared. So I'm going to simplify by cancelling out the 2 squared with the 2 cubed over there, where I have the higher power, that, or the higher exponent. That's where I'm going to end up with my result. So the 2 squared is going to cancel out completely, and the 2 to the power of 3 is going to change to 2 to the power of 3 minus 2 is 1. So I don't need to write the 1 there, but it's just 2 to the power of 1. That is being multiplied by 2 to the power of 4. There are no other 2's, so now I've got 2 to the power of 1 times 2 to the power of 4, giving me 2 to the power of 5. Okay, so in my numerator, I end up with 2 to the power of 5. And then let's have a look at our 5's. So I've got 5 and 5 squared. So the higher exponent is in the denominator. So the 5 at the top is going to cancel completely. The 5 at the bottom is going to, or the 5 squared at the bottom is going to change to 5 to the power of 2 minus 1, which gives me 1, or just 5. So that's going to be over 5 over here. So I end up with 2 to the power of 5 over 5. Now again, just like in the previous one, this is one that you should change, because 2 to the power of 5 is one that you should know. You should know that 2 to the power of 5 is equal to 32. Okay, so that's 32 over 5. Right, so that is what you should have got for question B. Right, let's go on to question C. In question C, we've got the square root of a fraction which contains 5 to the power of negative 4 and 4 cubed at the top, and 2 squared times 5 to the power of negative 2 at the bottom. Okay, so I'm going to give you 2 minutes to simplify this. Okay, so let's go through that question and see what you should have got. So just like in the previous ones, the first thing I'm going to do for this one is I need to get rid of the negative exponents by moving the powers that have negative exponents. Okay, so over here, in the numerator, the 5 to the power of negative 4 needs to move. The 4 cubed is going to stay where it is because it already has a positive exponent. So it's 4 cubed times, and then in the denominator, I've got 5 to the power of negative 2 that's going to have to come up and join it. So that becomes 5 to the power of positive 2. That is over. At the bottom of the fraction, I already have 2 squared, which is staying behind, or staying where it is because it has a positive exponent, but the 5 to the power of negative 4 has to move down, and it becomes 5 to the power of positive 4. Okay, then that is still all inside my square root sign, like that. Okay, so now let's go and see what we can do to be able to simplify this. Before I'm going to start actually cancelling things out, I want to make sure that I've got bases that I can work with. So this 4 is going to change to 2 squared. So I have 2 squared in brackets cubed times 5 squared over 2 squared times 5 to the power of 4. The only one that I had to change the base for here was that 4 changing to 2 squared. Okay, and that is all still inside my square root sign. Okay, so now we're going to get rid of those brackets. That becomes 2 to the power of 2 times 3, which is 6, times 5 squared, all over 2 squared times 5 to the power of 4. Okay, and then I've got my square root sign, which isn't going anywhere yet. And now I'm going to go and simplify my fraction. So in my fraction, I've got 2's and I've got 5. So I'm going to simplify my 2's. The higher exponent is at the top. So that's going to be 2 to the power of 6 minus 2 is 4 at the top. And at the bottom, that's going to cancel out completely. And in my 5's, the higher exponent is at the bottom. So the 5 to the power of 2 is going to cancel completely. The 5 to the power of 4 is going to cancel, giving me 5 to the power of 4 minus 2, which is 2. Okay, so I'm left over here with 2 to the power of 4 at the top of my fraction and 5 to the power of 2 at the bottom of the fraction. Okay, and that is still in the square root sign. Okay, now we're going to go and sort out the square root. Okay, now that we have simplified this as far as we can now go and sort out our square root. Now remember, when you take the square root of something which has, or of a power, we take the exponent of the power and we divide it by the root index. Now you can't see the root index, but remember, when you can't see the root index, it's a 2. So we're going to divide the exponents here by 2. So this is going to become 2 to the power of 4 divided by 2 is 2 over 5 to the power of 2 divided by 2, which is 1. So that's just 5. And this obviously we can simplify and write as 2 squared, which is 4 over 5. And that is one that you obviously are expected to change because you should know what 2 squared is. Okay, so that's what we should have got for question C. And now we're going to go on to the last one for today, question D. We've got a little bit more going on in this one. You've got in brackets in the numerator 3 to the power of negative 3 times 5 to the power of 7, and that's all squared. That's over 15 to the power of 5, and then all of that, the whole fraction, is in brackets to the power of negative 2. Okay, now I just want to warn you for this one, you need to be careful. You are not going to be able to move this negative exponent right from the start. You're going to have to first get rid of these brackets. Because the negative exponent, the power with the negative exponent is inside brackets, you can't move it because you're going to end up then taking it out of the brackets and then you won't have squared it yet. So you need to make sure that you first square those brackets and then you continue as you normally would. Okay, so I'm going to give you 3 minutes for this question. Okay, so let's go through that question and see what you should have got. So over here, in my question, normally I would take this power with the negative exponent and I would move it to the bottom first. But in this case, I can't because it's inside these brackets. And if I try and move it now, I'm going to end up taking it out of those brackets without actually doing what the brackets are there for. Okay, so I need to first sort out those brackets before I can worry about moving that if it still has a negative exponent. Okay, so now let's go and see what we get when we get rid of those brackets. So I've got 3 to the power of negative 3 being squared. That's going to be 3 to the power of negative 3 times 2 is negative 6. So it's still going to be a negative exponent because a negative times a positive is negative. Times 5 to the power of 7 squared. The base stays the same, so it's still 5. And then the 7 times 2 gives me 14. Okay, so I have 3 to the power of negative 6 times 5 to the power of 14 at the top. And then at the bottom, what I'm going to do now already, in the same step, because there's nothing else happening there that I need to worry about affecting anything else, is I'm going to change this 15 now so that I have fewer steps to worry about later on. And I'm going to change that so that it is in terms of 3 and 5. So 15 is the same as 3 times 5. So that's going to be 3 times 5, and that's to the power of 5. Okay, and that is all still to the power of negative 2. I'm not doing anything with that yet. Okay, so now my next step, I'm going to do a couple of things in the same step. I'm going to take this 3 to the power of negative 6, I'm going to move it down, and at the same time, I'm going to get rid of these brackets over here. Now, you can do it all in separate steps if you want to, but I'm just doing it in the same step because they don't interfere with each other, so I can. Okay, so the 5 to the power of 14 isn't going to change. It's still going to be up at the top here. At the bottom, I'm going to have the 3 times 5 to the power of 5. I'm going to get rid of these brackets. That's going to be 3 to the power of 5 times 5 to the power of 5. And then I also am bringing this 3 to the power of negative 6 down to join them. So that's going to be times 3 to the power of 6. Okay, so that is what I have at the moment. I've got 5 to the power of 14 over 3 to the power of 5 times 5 to the power of 5 times 3 to the power of 6. And it is all in brackets to the power of negative 2. Okay, so now what I've done so far is I first got rid of those brackets. And then I also changed the 15 to be in terms of 3 and 5, so that I'll be able to work with it with the other bases that I've got over here. And then I went and got rid of those new brackets that I had put in there, giving me the 3 to the power of 5 times 5 to the power of 5. And I also moved this down because it had a negative exponent. So that's what I've done so far. Now what I'm going to do next is I'm going to go and simplify what I've got in this fraction over here by working with the powers that have the same base. Okay, so over here I've got a 5 at the top and a 5 at the bottom. So 5 to the power of 14 over 5 to the power of 5. That's going to give me, if I simplify this, there's more, the exponent in the top is bigger. So it's going to be 5 to the power of 14 minus 5 is 5 to the power of 9 at the top. Okay, and this cancels out completely. And then in terms of my 3's, I don't have any 3's at the top. I've only got my 3's at the bottom, which I'm going to be multiplying together. And when I multiply powers of the same base, I add their exponents. So I'm going to be adding the 5 and the 6. Okay, so let's go and see what we get over here. So in the top, I've got 5 to the power of 9. And at the bottom of my fraction, I've got 3 to the power of 5 times 1 times 3 to the power of 6. So the 3 to the power of 5 times 3 to the power of 6, the base stays the same. And I add the exponents. 5 plus 6 is 11. So that's what I've got inside over here. And this is still to the power of negative 2. So now I'm going to go and sort this out. Now I can do this again in 2 steps, or I can do it in 1 step. I can first sort out my negative and flip it over, and then go and square it, or I can do it all together at one time. And that's what I'm going to do. I'm going to do it all together at one time. So because it's got a negative, I'm going to be flipping this fraction over. I'm going to be inverting it. So the 3 to the power of 11 is going to end up at the top. The 5 to the power of 9 is going to end up at the bottom. And at the same time, I'm going to multiply the exponents by 2 because it's not just to the power of negative 1, it's the power of negative 2. Okay, so now I'm going to have the 3 to the power of 11 going to the top, and then I'm squaring it, so it's 11 times 2 is 22. So the top of my fraction is going to be 3 to the power of 22. And the bottom of my fraction, the 5 to the power of 9 is going to go to the bottom because I'm inverting the fraction. And then I multiply the 9 by 2, and that gives me 5 to the power of 18. And that's what you should have got for that question. And that is how we work with the laws of exponents, including negative exponents. Now that we've learned the concepts in this lesson, it's important to practice, practice, practice. If you haven't already got the worksheet that goes with this video, you can find it by clicking on the link in the description below. The worksheet comes with an extra exercise full of questions for you to work on to master the concepts covered in this lesson. If you found this video helpful, please hit the like button so that others can benefit from it too. Also, be sure to subscribe so that you can easily find my other lessons, and hit the bell so that you will get notified about lessons as I upload them.